Welcome in, everybody. We are at the end of week one. Going to cover lesson number 2 today. Lesson 2 is about using more features on the turtle. By the end of today, we should be able to get lab number 2 done. Lab 2 is a separate notebook that we'll be submitting. It's due on Friday, I believe. Generally, every week, there's a lab due at the end of the week. And these deadlines are available on the assignments. So lab week 1, this is February 7th. A few more days. Once again, we should be able to get this done today. There's going to be a lot of time in class to get it done. We're pretty much going to take a couple breaks in between the lesson and kind of fill in the blanks for this lab. By the way, some folks turned in a lesson for the lab. We're not turning any lessons in. The lab is a separate notebook. We'll see that in a bit. The separate notebook is located in the home directory in this other folder. Okay, let's get started on lesson number 2. Number 2, we're going to be introduced to a couple or several more features on the turtle. This will help us visualize the basics of algorithms. Basics of algorithms meaning we can see code as a series of instructions. We're going to see kind of 2 different ways of moving a turtle. Last class, we saw one way where we had to manually move the turtle. We had to manually rotate it, right? So going back to lesson 1, we saw a tiny sneak peek on this, right? A tiny sneak peek where we had to do moves and turns, right? That's one way, right? We're going to see another way towards the later half of class. Another way of moving a turtle is by controlling the coordinate system. Are folks familiar with the X and Y axes? Okay. Yeah, if you're familiar with the X and Y axes, like this right here, coordinate system. All right, we're going to see this in the later half of class. All right, so the coordinate system is like a 2-dimensional. All right, so try to envision a turtle in a coordinate system. One other way you can move it is by telling the turtle to be at a certain position. This might be easier than kind of manually moving and turning, moving and turning. All right, we'll touch on that later. Let's still keep talking about the moving and turning. We're also going to hit the lab in just a bit. So if folks want to load it up, the lab is right over here, just in the home directory over here, and then lab on the algorithms. So I'm going to load both these up. Now both these tabs are open. Let's go to the lesson though. All right, we're going to switch back and forth a few times. All right, people cool with that? Loading up the lab and lesson. Okay. All right. I'm going to run this first cell. This cell imports the library that allows us to use the turtle and all the functions. All right, we're importing it as TU, meaning that any future references can be shortcutted with this TU right here. Short for turtle. Zoom in a bit. All right, as we saw last class, the turtle has access to a class function called .new. This creates a blank canvas. I'm going to run that. All right, we saw some moving and turning. All right. By the way, in these next code blocks, I'm going to prefix the beginning of it with new, meaning that every code block will start fresh. We're going to do a whole new canvas on every block. So I'll run this one, and we saw that moving up goes 100 pixels up. Okay. Functions take inputs. We've seen the input being a positive number. It can be negative too. A negative number will make it move backwards. So if we run this right? Move it up 100, and then a negative number as an input will make it go backwards. So we'll run this, and yeah, it goes. The turtle goes up, and it goes backwards 50 pixels, about halfway. Okay, so yeah, that's just using the move. We can do the same exact thing with the turn. If you might be familiar with a turn, the input to the turn function represents the degrees in counterclockwise. Here, so let me just take this kind of. I'm going to comment out these last half lines just so we can visualize this a little step by step. All right, so I'm gonna highlight these last 3 lines. One easy way of commenting things. There's the keyboard shortcut. I think it's Control/. But yeah, I'm just gonna disable these lines just so we can visualize it. All right. Yeah. Mm-hmm. Oh yeah, good question. Yeah, yeah. If anyone is getting an error message that says TU is not defined, most likely have to rerun the very first cell, which brings the library in as a as TU. Yeah, you're gonna have to run this even after you refresh the notebook. Nope. Yeah, yeah. I didn't edit this cell at all. Yeah, I'm not editing any cells yet. Yeah, yeah. Good questions. Yeah, we're kind of just pressing play on every cell. But yeah, going down to the turns, I did edit this a bit. Once again, I commented out these last 3 lines, which disables the lines of code. And we have access to the turn function. I turn it 45 degrees counterclockwise. So if we press play on that, it looks like this right here. It goes up, and then it rotates counterclockwise 45 degrees. These degrees also work with the negatives too, right? Like if I were to move it again, I move it again 30, so it's going to go forward 30. And press play. Okay, let me zoom out a bit. It keeps every time I press play, it brings me to a different area of the notebook. Super annoying. I have to zoom out. So the turtle moved 30 pixels in that direction, and now we can enable this line right here. Right, -45. This is a clockwise by 45 degrees. And so let's see. Let's visualize that. Okay, I just ran that, and now it goes back in the original direction, north. And then get the last line right here. Press play, and it's now it's going up, right, 30 pixels. All right. People cool with this so far? Okay. Let's apply this to the lab. We're going to take a 10 to 15-minute intermission for folks to load up the lab and finish up part 1. We should be able to get part 1 done. The whole goal of this first part is to draw some shapes using move and turn. Right, so there's some tutorial here. Make sure to kind of brief over it. But the whole goal of the lab is to fill in these blanks down here. Right, we should be able to get part 1 done. There's no need to get to part 2 yet. We'll do that later. And we're going to jump back and forth. So yeah, part 1, we're going to use the move and turn to draw a square. Oh, but by the way, to help folks get started on this, let's prefix every code block with a new canvas. Yeah. Oh yeah, good question. Where's the labs? It should be in the home directory. You might have to go back a bit. So yeah, click on your the file explorer. Then oh yeah, it looks like George got you. Nice. Yeah. Yeah, for folks on the recording in the Zoom, in case you don't know how to go to the lab, click on this top left right here. This is the file explorer, and you might have to go home. Right, go home, like go backwards, and then it should be in the labs. So there we are. Once again, we're only going to do part one for now, and we'll do part two towards the later half of class. Just make sure to prefix each of these blanks with a new canvas. This way we're not reusing the same canvas over and over again. Right? Every part will be different. For example, here we draw a square, and then here we're gonna draw a capital T. Right? So I'm gonna do a new canvas here, and then another new canvas. All right, and once again, also don't forget to run this very first cell. Okay, go ahead and give part one a try. We're gonna come back in like 10 to 15 minutes. I'm also gonna walk around the classroom, make sure people are all good. And I'm gonna pause the recording here. Okay, we're back from the intermission. Let's go over this together. Don't worry if it wasn't complete. We'll fill in the gaps right now. However, I highly recommend trying it out yourself. If you're on the recording, please try it out yourself before copying down the solution. It'll kind of exercise the problem solving concepts a lot better. Okay, we're doing part one. Make sure we run this cell, the import, which allows us to use a turtle. Right, and then going down to part one. Oh, I'm on the wrong notebook. My bad. I'm supposed to be in this lab. Okay, so in the lab, run this first cell. There's an example cell down here. You can run it. It's pretty much drawing a bunch of lines and kind of demonstrating the functionality of moves and turns. I'm not going to run it, but yeah, feel free to run it yourself. We want to draw a square on the first one. We did this in last class. Right? Last class, we drew a rectangle, we drew a square, which consisted of 90-degree turns. Right? If folks are familiar with the degrees, right, turning a certain amount of degrees tells the turtle to rotate. Right, so here, let's start small. We got a new canvas here. One way we can draw a square is by starting the turtle moving up 100. So we could go ahead and move it up 100. Right, tu.move, and then maybe 100 pixels. All right, so there it is. It went up 100 pixels. And some people rotate it to the left and some rotate it to right. It doesn't matter which way you rotate it, but the degrees do matter. Right? If we want to rotate it counterclockwise to the left, those would be positive degrees. If we want to rotate it clockwise, those would be negative degrees. Right, so I'm just going to choose one. I'm just going to choose right. Right. Let's say we want to go clockwise. So we're going to rotate it by negative 90 degrees, right? Because 90 is a right angle. All right. So let's push play, and there we go. See, it rotated, and now we should probably move it again. All right. So I'll go ahead and move it. Tu.move 100, and then do the same exact thing. Right. Now the turtle needs to rotate again in the clockwise. Right. So same thing. Tu.turn negative 90. Right, that'll do the right angle. Okay, now it's looking in the right way, and hopefully people kind of see how to complete the rest of the square. Right, we can pretty much copy and paste these two directions. with these two little blocks, and they should complete the square. By the way, I'm inserting vertical white space here just to make things look more readable. All of your things can be compressed, but in my opinion, this is more readable. Okay, there we go. Now we finished the square. All right, let's move on to the next one. This is a T, right? Draw a capital T. Okay, so same thing. If you can do the square, you can probably do the T as well. So we're going to kind of do the same stuff, right? Let's go ahead and move it 100. All right, so it went up 100, and once again, we can go left or right. Let's go left this time, right? So let's go left. Let's move it. Turn it counterclockwise in a right angle. So 90, and there we go. It's looking left. Let's go ahead and move it a tiny bit. Maybe I'll move it 50 pixels this time. And there we go, move 50 pixels. Okay, now we need to make the turtle face the opposite direction. Right, so to make it face the opposite direction, this is going to be 90 plus 90, so 180 degrees. Right, 180 degrees means to flip the turtle around. So tu.turn 180. Right, by the way, negative 180 and 180 is going to give the same exact result. Okay, so there we go, 180, and now it's facing the opposite direction, and now we just got to move it. Right, in this case, maybe move it 50 plus another 50. So I'll go ahead and move it 100. tu.move 100. And press play. Okay, cool. There we go, we moved it 100. Oh, someone in the Zoom chat had a nice shortcut. Thanks, Joe, for that recommendation. Yeah, so Joe says they did a negative 100 move instead of the 180. So here, let's back up a bit. Another approach we can do. All right, so backing up a bit, let's say our turtle is right here. All right, we don't really have to turn it. You can just have it move backwards by 100. So tu.move and then negative 100. It should move backwards. And yeah, there we go. Yeah, nice. Thanks for the recommendation, Joe. It's a good one. As we'll see in this course, there are multiple solutions to certain problems. There's not just one. Okay, let's do the A. I think this is probably the last one I'll do, and folks can probably do the other ones. So for the A, this is a tiny bit trickier because we're not really dealing with right angles. Right? We're dealing with angles that are a little, yeah, not fully 90 degrees. So let's see the turtle starts here. All right, there's multiple approaches. Let's say we wanted to move the turtle this way right here, right, in this direction of the mouse. This means we need to rotate it clockwise a tiny bit. All right, let's try tu.turn maybe negative 30, right, just a tiny bit. All right, so let's see. Okay, it's looking good. Let's go ahead and move it. So tu.move, let's go 100. Okay, tu.move 100. Sweet. All right, there's multiple approaches again. All right, now we need to make the turtle face down this way. Right, meaning that we need to rotate it counterclockwise again, so but by a certain amount of degrees. All right, so some people might be kind of guessing and choosing. If you took some sort of math class, you might find it a bit easier. It's okay to kind of guess and check. Like, maybe, let's see, turn negative 60, right? This is just total guess. So turn negative 60, right? See, that wasn't enough. So let's try negative 90. And that looks almost there. So let's go negative 120. Right? It's okay to guess and check. The reason why is because there's no math prerequisites for this class. But yeah, if you did take trigonometry, this would be a lot easier. But yeah, it's okay to guess and check. Okay, so negative 120, and let's go ahead and move it now. tu.move 100, and let's go ahead and run this. Okay, it's looking a little better. All right, now we just need to kind of move the turtle back up a bit and complete the rest of the A. Okay, so I'm just going to move it back up a bit, maybe negative 50. So tu.move, make negative 50. This will go halfway up here. So should go halfway up, and there it is. Now we need to make the turtle rotate counterclockwise again and move a bit. So I'll make it move, turn counterclockwise, probably by 120, negative 120 for counterclockwise. Okay, there we go. And now it's facing the right direction, and we can move it and be done. someone in the Zoom chat says, what's the actual angle of A? Yeah, good question. We'll need a protractor for that. All right, now we just got to move it. Let's just totally guess. I'm just going to guess maybe 50. Let's see if 50 is enough. Okay, 50 seems like enough. Sweet. So yeah, there's our A. I hope people are cool with this so far. Yeah, George. Yeah. Oh yeah, that's close enough. All right. Yeah, it's a different font. Yeah, cool. Yeah, so someone in class just asked how precise the A needs to be. It doesn't need to be that precise. Our next assignment will have us draw a certain shape. And yeah, that certain shape doesn't have to be too precise, as long as it represents the shapes that we need. All right. I think that's all we're going to do together. I'll leave folks to do this for homework. Escape the maze. All right, number 4 wants us to use this background and move the turtle a bunch to get to this exit right here. All right, so you want to put your code below this line, and it'll move the turtle. I'll let folks do that yourself. Okay, so that's it for part 1. Let's see, someone did draw an M earlier. For folks who are looking a bit ahead, that's fine. For drawing this M, we don't want to use the functions move or turn. We haven't covered really how to do that yet, so let's cover that. We'll move on to part 2 in just a bit. Let's go back to lesson number 2. All right, going back to lesson number 2, we left off over here, picking up and putting down the pen. Wait, actually, before we move on, are there any questions on the lab? On part 1. All right, I'm gonna collapse this part 1 then. So this arrow key. All right. Picking up and putting down the pen. We're going to be introduced to some more functionalities of the turtle. Right, the turtle can do a lot of things. For example, we can pick the pen up and it will not leave a trail. Right, so let me take this step by step. I'm going to comment out most of these lines just to kind of visualize what's going on. So let's say the turtle starts moving up 30 pixels. We can pick the pen up. Right? Picking the pen up means to kind of lift the turtle. Lift the turtle and don't make a trail anymore. So let's say I pick up the pen right here. Pick up the turtle, and then go ahead and move it. So I'll move it 20 after that. All right, as we see, there's a little gap. All right, there's a tiny gap because we moved it, we picked it up, and then we moved it a tiny bit again. And similarly, we can put the pen down, the opposite of it, right? Put the turtle back down, and then move it again. And yeah, we see that it draws a line now because we put the pen back down. Are people cool with this? This is extra functionality. Right? Okay. Yeah. Oh yeah, we're on the lesson number 2 now. So we're not in the lab anymore. We switched to the lesson, and yeah, we're gonna finish the rest of it, which will allow us to do the rest of the lab. Okay. Some more functionalities of the pen. We can change the color and the width. Right? These are called properties. So far, we have been dealing with things called functions. Right? Functions, you can think of it as it has parentheses at the end of it, which can take an optional input. Right? These are all function calls. Let's talk about properties. They, you can think of it as the same thing, but without parentheses. So some properties of this turtle are, the color of the trail and the length, the width. I mean, the thickness of the trail. So let's say we were to modify some properties. All right. Once again, I'm going to comment out most of these lines and just kind of do it one by one. So I'm going to comment all those out. For folks who are wondering about the keyboard shortcut, I believe it's Control /. Okay. So let's start fresh. Let's talk about properties. I'll start a new canvas, but I'll set the property of the TU width to 30. Notice how there's no parentheses here. There's no parentheses because there's a difference between functions and properties. Right? A function is something that kind of performs an action, right? But a property doesn't really perform an action. It's more like a value. In this case, we're changing the value of this property to 30. We're also going to change the value of the color to red, right? Red in quotes. Right? We'll talk about why there's quotes here. Basically, this is a string. I don't think we'll cover strings until the next class. But yeah, a property is this red in quotes. We just changed 2 properties. Let's see what happens when we move the turtle now. Right, hopefully, people can kind of predict what's happening. Right, the width of the trail should be thicker, and the color of the trail should be different. Right, so let's press play and see what happens. Okay, there we go. See, it's thicker and it's red. People cool with what properties are, kind of. We got widths, colors. Okay. Sweet. And yeah, continuing on, we can keep changing the properties over and over again. All right, so let me just turn it a tiny bit. There we go, turn it a bit. Okay, you might not see it, but the turtle rotated. And we're just gonna draw some random lines. Let's change the property to green now. Right, green, and then move it and turn it. All right, so press play. And now we see that it changed to green, and we moved it 150 pixels and turned it. Right, you can do a lot of things, right? Like, once again, you can change the thickness as well. The thickness property is represented by the width keyword. Right, I'm just gonna set it equal to like maybe 1. Actually, no, I'll make it 2. It doesn't matter. We're just kind of playing around. Okay, there we go. And then it's now 2. Width 2, and it's green. Okay. And I'm going to uncomment out the rest of this. Are people cool with this so far? Changing the turtle's property. So the goal of this cell was to show the difference between functions and properties. Think of functions as a black box that does something. Right? This is a black box that moves a turtle in a certain amount of direction. But then the property, it doesn't have parentheses. Right? This is a value that belongs to the turtle, and we're just setting it equal to something. Right? Setting it equal to something means to assign. We're assigning the turtle color green. We'll talk about this in just a bit, but the flow of this assignment, the right goes to the left. Right? This is not like math. It's not like in math where you're comparing equality. In programming, the equal sign generally means put the right to the left. That's generally what it means. All right. Any questions so far about these little properties? Okay. We can print out the properties too. Right? These are values. We can put them inside of the print statement and kind of just visualize what it is. So if we were to go down to this cell and print out the value of the turtle's color and width, right? These properties will evaluate to what we had earlier. Our last color was blue, and our last width was 2. And this is information from the previous cell. Okay. All right. And then here's some extra stuff. You don't have to know too much about this. If anything, these are HTML color codes. It's like a hexadecimal. If folks have heard of hexadecimal, it is possible to change the color using hexadecimal notation. Right? We don't have to know this. This is just extra stuff. So you can totally do that stuff. Right? These colors, these values represent values in red, green, and blue. Right? Red, and then green, and blue. You don't have to know this. It's just extra stuff. All right, any questions so far? This library supports both the text and the string. I mean, in the code. But some other libraries might not support that. Yeah. Oh yeah, HTML. Yeah, you got to put the. I see. All right. Let's move on to a different way on moving the turtle. Lately, we've seen moves and turns. That can be a little cumbersome, right? As you might have experienced in the lab, you might have been kind of guessing and checking to make sure things are right. There is another way of moving the turtle. We'll kind of need to understand the coordinate system though. Try to imagine the turtle in a coordinate system that spawns at the origin. It is possible to change a certain property and make that turtle teleport somewhere. Let's talk about that teleportation. There is a property called position, right? POS. So let's look at this. I'm gonna comment this out for now. Take this one step at a time. We'll spawn a turtle, right? Spawn tu.new and print the value of its spawn point, right? The POS position. So let's see what the current position is at. So I'll press play. Press play. Okay, the turtle is here. The print statement is down below. All right, the print statement. The turtle is located at 0, 0. All right, this is the origin. We can change that position and make it teleport. It will teleport the position. The value on the right needs 2 coordinates, the x and y. So if you're familiar with the coordinate system, -100, -100, this is right here. Here, I'm just gonna press play, and people can kind of visualize it. So I'll press play. All right, people see why I went -100, -100. If you're not sure, if we look at the coordinate system, right, so the turtle starts at 0, and those 2 points represent the x and y coordinates. Right, -100, -100 brings us to the bottom left. Okay. Cool. That kind of teleported it. This is different from moving. Right? We didn't have to rotate the turtle nor move it. We just told it where to teleport, and it just boom right there. All right, let's see this one now. 100 and negative 100. Right, if we look at the coordinate system, 100 and negative 100 should be on the bottom right. Right, so 100 on the x and a negative 100 on the y. All right, so let's play this. And there we go. See, bottom right. See, that's the 100 and then negative 100. Right. The turtle's location still says is located at 0, 0. That's because we didn't really update the print statement yet. So hope this makes sense why it says 0, 0, even though that's not true. Right? It's saying that because the order of statements matter. Right? We printed out the origin. Later on, we're going to print out the end result. Okay, so let's uncomment the rest of this. Right, 100 and then 100. This should be on the top right. I'll press play, and there we go. See, top right, and then TU position. This should be on the top left. There we go. And finally, the print statement. Right, this will show the end result of where it's at. Right, in this print statement, we're having 2 arguments, by the way. I mean, 2 inputs. I forgot to specify this earlier. A print statement can take multiple inputs. In this case, we separated inputs by a comma, meaning that the values will be separated by a space. And we see that if we press play. So press play, and we see that right here. Turtle is now located over here, negative 100 and 100. That is the value of the last property. Negative 100, 100, that's right here. Are people cool with this so far? Some positions. Okay. All right. I think we can apply this to the next part of the lab. We just talked about using the coordinate system, right? In particular, changing the position attribute. The position attribute contains x and y coordinates. I think we can do the next part of the lab. Let me take a look. So let's switch to the lab. In part 2, we can get number 1 and 2 done. Don't do number 3 yet. There's actually a really nice shortcut that we'll cover. Right, but part 2 asks us to draw letters without using the move nor turn function. This means we'll have to use the absolute coordinate system. Right? It might be a good idea to load up this coordinate system on another tab and kind of maybe plot some points, right? Like maybe put a period on where you want the turtle to be and just kind of visualize it a bit. So it might be a good idea to draw this out. So we're not going to use the move nor turn functions. We're just going to modify the position attribute instead. All right, so let's give it a try. Let's apply that stuff. Once again, don't do number 3. We will see a very nice shortcut on this. Right, number 3 asks us to write your name 3 times. Right, doesn't that seem tedious? Yeah, it seems super tedious. We'll see a very nice shortcut in just a bit. So don't do number 3. You should be able to do number 1 and 2 though. Right, and once again, the hints are over here. Right, we just covered how to pick up and put down the turtle. Right, this controls where to draw the trail. We just covered the color and the width properties. And more importantly, the absolute coordinates, where we can teleport the turtle to a certain point. But yeah, let's go ahead and apply that. I'm going to give it like a 10 or 15 minute break. 10 or 15 minute intermission. Oh, and then someone in the chat let's see, says, oof, I wish I had an easier name to draw. Yeah, it's okay. I was thinking first name only. So once again, this last one will be a lot easier if we wait a tiny bit. Right? There's another function that will do all of this for us. Right? So don't do number 3 because it's going to be very tedious. Right? If you want to get a head start on it, you could look towards the bottom of the lesson. Right? Towards the bottom of the lesson, there's a section on writing text. Right? This will be covered in just a bit. Right? But I want to make sure folks can apply the absolute coordinate system. So let's go ahead and work on 1 and 2. I'm going to give it a 15-minute intermission. For folks who are watching the recording, please give it a try before we go over it. I'm going to pause the recording here. Okay, we're back from intermission. Let's do this together. We want to draw some letters without using move nor turn. I recommend drawing it out on pen and paper, or metaphorically, right? Like getting a graph and then kind of plotting the points here and there. If you've taken an algebra class, you might have heard of something called Desmos. This is a graphing calculator that most of them use. So I'm going to go to the graphing calculator and visualize the coordinate system here. Let me zoom out a bit, maybe to 100. The reason why is because our canvas defaults to size 100, 100. We want to draw an M for the first part. Let's focus on one quadrant for now. It'll be a lot easier if we focus on the top right quadrant. Right? These are all positive numbers. Right? So we don't have to focus on any negative numbers at all. Just this top right. All right. The turtle starts at 0, 0, the origin. Okay, hold up. There's a glitch right now in the projectors. Give me 1 second, folks. Our turtle spawns at 0, 0, meaning that whenever we make a new, whenever we type in tu.new, right, it spawns at 0, 0. All right, sorry folks for pausing. These projectors are overheating. Okay, our turtle spawns at 0, 0. We want to maybe focus on this first quadrant, right, on the top right. Maybe move it all the way up here to 100, right? So we want to draw the M, right? You can do however you want. I'm just going to go all the way up to 100. So 0 on the X and then 100 on the Y. So let's change that POS property, the position. Right, once again, there's no parentheses after here. Right, this is a property, meaning that we're going to assign it to some coordinate. In this case, 0 and 100. So let's see what this looks like. Okay, 0 and 100 looks like it goes up here. Okay, now we need to move it down here a bit. Right, once again, this will be a lot easier if we visualize this on the graph. Right, so let me just graph this out a bit. So 0, 100. Right, 0, 100 is over here, this red dot. Now we want to go maybe somewhere down here. Right, it's totally up to you. Maybe we could go to 40, 60. Right, 40, 60 is right here. 40 and then 60. Right, maybe we want to move the turtle down here. So let's do that. Let's change the POS property to 40, 60. 40 and then 60. All right, let's see what it looks like now. Okay, there we go. It's looking good. Now we want to move the turtle over here. We want to teleport it, right? Not move nor turn. We're just going to teleport it over here somewhere. I'm going to go back to the graphing calculator and visualize it. So maybe we want to put it somewhere over here. Right? This looks like 80, 100. Right, let me just verify that with 80, 100. Yeah, that looks kind of right. 80, 100. Let's test that. Let's go tu dot position is equal to 80 and then 100. 50 on the second. Oh, yeah. Let's see. 50 on the second. Oh, I see what you mean. I see. Yeah, so someone on the Zoom chat was recommending to lower this point. Yeah, we could do that. Yeah, we could put it to 50. Okay, let's do that right now. So 40 and then 50, and then next would be 80 and then 100. So right here is 80 and then 100. Okay, let's see what it looks like. Looks okay. Right, it definitely could be a little more precise, right? Like maybe boom, boom, 2, 80 and 100. Okay, yeah, I'll let folks play around with this. But finally, we need to move it down. Right, down. This is same. The middle of the M. Oh, someone on the Zoom chat says the middle of the M goes down to 0. Yeah, I'm not going to be too precise about this too much. You can feel free to play around with it and kind of change the font of it, as long as you understand the point of moving the coordinates. So I'm just going to move it back down here. Tu.pos is equal to, it's the same on the x-axis, right, and then 0 on down here. So it looks kind of good. Yeah, looks okay to me. All right. Okay, that's for the M, right? We used a graphing calculator to visualize each point. Let's move to the X, right? This X right here, there are multiple approaches we can do, right? Someone earlier mentioned that we might not have to pick up the pen up and down. There's multiple approaches. For this one, I'm gonna pick the pen up and put it back down, right? There's multiple places we can start, right? Like let's say we spawn the turtle at 0, right? Tu.new spawns it at the origin 0, 0. In my opinion, it might be easier to look at one quadrant only. So focusing on the first quadrant, the top right, maybe if we wanted to draw an X, maybe we could put it to 100, 100. Right, so we could put it to the top left corner. Right, top left corner, 100 right here, this dot. So we could do that. Okay, so tu dot position will teleport it to 100, 100. Right. So that's one way. You know, next we need to draw the other part of the line. Right. So we need to teleport the turtle over here, right? The top left of this quadrant. Right. This is represented by 0, 100. Right. Hopefully people will see that. So 0, 100, right, is over here, this black dot. Right? We want to teleport the turtle there and then draw the diagonal line. Right? Once again, this is just one way. There's so many different approaches. Right? So let's go ahead and teleport it. So tu.position is equal to 0 and 100. All right, however, we see a problem. This is not an X. There's a trail here. We might need to pick up the pen between these two teleportations. So let's pick up the pen here. As we've seen in the previous lesson, there is a function, right, called pen up. Right? A function has parentheses right after it, right? Not an equal sign. Right? So we could pick up the pen and move the turtle there, and it won't leave a trail. All right, see, we picked it up, moved it here, and now we should probably put it back down. Right? Put it back down so we can draw the other line. So I'll go ahead and put it back down. Tu.pen down. Yeah, tu.pen down. And then, so that will put the turtle back down. It will be able to draw a trail. Now we need to put in the bottom right of this quadrant. Right? This is represented by 100 and 0. Right, once again, we can verify that right here. Right, 100 and then 0 is over here in this red dot. Okay, let's do that. tu.pos is equal to 100 and 0. Cool, there's a kind of an x. All right, once again, there are an infinite amount of approaches to do this. The whole goal of this cell was to practice absolute coordinates and picking up the pen, putting back down the turtle. Oh, yeah. If folks weren't here for the pen up and pen down, you can always go back to the lessons somewhere over here. Yeah, picking up and putting down the pen. Sometimes when you're at home, you might find yourself reviewing the lessons again. That's recommended. I highly recommend reviewing lessons again to kind of reinforce the knowledge. All right, we just finished almost part 2, right? We did draw an M and draw an X. I asked folks to skip this very last question because we're going to see a very nice shortcut in just a bit. Are there any questions about this before we move on? Okay, let me collapse. No, I'm not going to collapse it. Let's go back to the lesson and finish it. Got 15 more minutes left in class. We're going to finish just on time. So going back to the lesson, we left off after the absolute coordinate section. Controlling the pen's heading. Let's see. I'm going to skip over controlling the pen's heading. This is another way of turning the turtle. Basically, you can tell the turtle to, I'm not going to skip it. I'm just going to briefly go over it. Basically, you can tell the turtle to look north, to look left, look down, or right. You don't have to rotate it manually. If folks are curious, there's degrees. It's like a circular. I wish you could see my whiteboard. If folks were here, imagine a circle, right, where 0 is looking up. And then if you say 90, this means west, and then 180 means south, and 270 means east. Right, so kind of imagine these, meaning that we don't have to turn anymore, right? Like let's say we start the turtle at here, right? We could change the position. Right? This is different from the turn, by the way, right? So facing left 90, right? It's different from turn. Right? It's possible to do the same exact thing with the turn function, right? But yeah, this is just an alternative way. We can move it 100, and then make it face down. Right? Once again, when we change the heading to 180, this is not rotating it 180. It's saying, it's kind of like a teleport. Right? It's like teleporting, but rotational wise. It's saying face down, face south. So we'll face it south, and then now it's facing south. And then tu.move again. And yeah, it goes down. Right? And you can print out the position as well. It prints after the turtle. For a fun thing, let's do the same exact thing, but without the properties. Right? I just want to show kind of the differences between modifying the properties and this stuff right here. Right, so I'm just going to do the same exact thing just to show that there's multiple ways. So I'll spawn another turtle here. Right? Instead of making the heading face west, we can just have it rotate 90 degrees counterclockwise. Right? tu.turn 90. Right? See, it looks almost the same. Right? We make it go left, right? and then move it tu.move 100. I think, yeah, 100. Right? Move 100, and then now the difference here, right? the previous cell, we made it face down. Right? This is not a rotation. This is like saying, make it face south. Right? This is not rotating. But for our case, this another approach, we're gonna rotate it by 90 degrees clockwise. Right? See, same thing. But the difference is, this is not teleporting. Right, and then we can move it 100. Okay, there we go. See, we got the same shape, but with different ways. Right? The first way, we just modified a property. It's kind of like teleporting. And then the second way, we rotated it manually. All right, so multiple ways. All right. Oh yeah, someone in the chat, Joe says like a clock. Yeah, exactly. Yeah, we can think of these numbers like a clock. Yeah, good analogy. Okay. Okay, we're almost done. This is the part where we see a shortcut for writing text and be able to finish the rest of the lab. Let's do this step by step. I'm gonna comment out everything. We'll spawn a turtle in the middle. You might have seen that it was tedious to draw letters. Well, let's put the pen up actually. You don't need the pen down to use this function. There's a function that will draw the letters for us, right? So I'll play this. The turtle will start at 0, right? We picked it up, and then it's gonna dump some text, right? So let's see. There we go. It just dumped text right there. Right? We don't need the turtle to be down. It's a different implementation. So now we're introduced to a new type of function. It's a dot write. This function takes an input of text, right? We can put text in here, and the turtle will just dump out the text like that. Okay. We can turn it and move it. So let's see. Let's turn and move. Okay, the pen is up, so it's not going to leave a trail, right? It's just gonna move in a different area. So let's see what it looks like. Okay, it dumped Python. We turned and moved it this way. Right, so now the turtle is looking in a different direction. Let's dump some more text, right? Like is. Right, so I'm just gonna dump a text there and see what it looks like. Okay, there we go. You can't see it, but there is the word is right there, rotated. Okay, let's do one more. Let's move the turtle somewhere else. Right, turn, move. Okay, now the turtle is in a different area. It's over here, right? It's in a different rotation, the different position. Let's write something. We'll write fun, and then move it. This way it doesn't cover the words up. There we go. The Python is fun. This is, the point of this is to show the write function. Pretty handy, right? Yeah, super handy. Okay, with that in mind, you should be able to get the rest of this lab done. Right, I'm not gonna go over it. Pretty much you wanna write your name 3 different times using 3 different colors, meaning that you'll be using this write function. And also changing the color property. So please refer to the earlier cells about changing the color. Right? Earlier over here, we changed these properties by setting the color equal to some text. So folks should be able to get the lab done now. Except what? Oh, the maze. Yeah. The maze you have to do on your own. But I hope folks got that. This one right here. I didn't go over this in class, but yeah, give it a shot. Once you're done with the lab, let's talk about how to submit it. So the lab is right here, lab week 1. This is due on Friday at 5 p.m. Right? We want to download the notebook and upload it here. Here, let me view as student. So we want to go to the Jupyter Lab, download it. You know what? Make sure you save it. I keep forgetting to mention this. It's pretty important to save frequently. I haven't been doing that. So I'm just going to save it, or Control S. Once you save it, go ahead and download it. Right? If you don't save it, you're going to end up downloading an empty notebook. So download it, just right click here, click download. This will download the notebook onto your local computer where we can upload it. Right? We can go here and then upload, see, or drag it here. Right? So I'm going to click here and then upload it. For me, it's right here, lab LO2. Let me sort it by date modified. Right, see, for me, it's right here, and then I'll just submit it like that. Right, see, it's uploading, and that is the lab notebook. So that's how we turn in labs. People cool with that so far? Save, download, and upload. Okay. Let's finish the rest of this lesson, and we'll talk about the hints for the next homework. We're almost done with this lesson. There are so many different functionality to the turtle. I feel like we're getting information overload right now on different things we can do with turtle graphics. Right, so let's keep it brief. Right, we can review this later to revisit the features. Right, another feature is moving and hiding the turtle. Right, there's hiding and showing. Right, so let's say we were to spawn another turtle and move it. Right, we can hide it, meaning that the turtle will disappear. It'll be invisible. So I'll hide it. There we go. See, it moved it, and now it's invisible. All right, the opposite of hide is to show. So you can do some commands here and then show it later, and it'll reappear. Okay, so that's another functionality: show and hide. See, drawing a polygon. I think I'm going to skip over this just so we have some time to go over the homework. We don't need to know this for the homework. Right, drawing a polygon, this is kind of like extra stuff. Yeah, you can go over this yourself. I would consider this optional topic. The reason why is because we haven't really covered this with keyword yet, and we don't really need this polygon function to get the homework done. So I'm going to skip over this polygon stuff. It's optional. Oh yeah, someone in the chat says, yeah, using the right function defeats the purpose of the turtle. It defeats the purpose of the turtle when writing text, but not when drawing shapes. Okay, once again, we're skipping over draw a polygon. I'm going to collapse this. Totally optional. Just a few more things, a few more functions. Please take a look at this as a homework. We can set the background, right? You'll see this in the lab. Right, we set the background, tu.background, and the input to this function is the location of where the picture is. Right, the location of the picture is in the lab files and then maze.png. Right, if you're curious, that's right here. So I'll go into File Explorer. It's in Labs, and then Files, right? Files, and then maze.png. This is the photo, right? So we can set the background to whatever you want. Okay. We can also change the shape and size of the arena. This is a property. Right? In this case, we're spawning a turtle. We're changing the size of the arena to 100, 100. So it's going to be a very small arena. Right? It might not look like it, but the size of the arena is now right here. Right? I don't think you'll need to use this for the homework, but yeah, just letting folks know there's so many different things you can do with the turtle. It's information overload, and you can look at the help. In Python, there is a function called help that takes an argument of whatever you want help on. So we can put tu in here, and it'll give us documentation on the turtle. Right? documentation meaning available functions and how to use it. For example, this is a bunch of text. This text came from the library. Whoever built the library wrote good documentation. For example, hide, right? We just used this earlier. Right? There is a hide function. So tu.hide will make this turtle disappear. Right? We use the pen down. We use the pen up. We use the turn, right? Turn, and then it takes an argument. Input. The input is the amount of degrees. Right? There's a right function. There's a bunch of arguments, inputs here that we can use, like an optional font. And here's the properties, right? Moving back down a bit. Some properties that we've used are the color. Right? We change the color. We talked about the heading, the position, right? The size, the width. All right. Once again, this documentation does look dense. You might not end up using all of it. Okay, with 1 more minute remaining, we just finished this lesson. We skipped over the polygon stuff. It's not too important. Let's talk about the assignment. We have enough to get it done now. The assignment will require us to download and upload. Assignment is located over here in the week 1 RobotCat. So this is due next Thursday. So I'll click into here. This notebook is not in your server, meaning that we'll have to download it and upload it to your server. Right, so make sure to download this right here. So I'll click this download button. Boom. Okay, it finished downloading. Right, so now the notebook is on my computer. Right, so we're pretty much transferring from Canvas to the server. Right, we went from Canvas, we downloaded it to our computer, and now we need to upload it to the server. So go to the server. Let's upload it here. Let me exit this stuff. I recommend having a bit of organization, meaning in this file explorer, maybe make a whole new folder. Right? We can make a whole new folder right here. Right click it and then click on new folder. I'll call this something like projects. Right? Let's have a bit of organization. The reason why is because when we upload it, I recommend not having every single file in one directory. Right? Maybe have a separate projects directory. So I just created a projects directory. We will have multiple projects. So maybe this one, I'll create another folder. Right? I'll create another folder and call this one week one RobotCat. Okay, so basically I'm just promoting some organization. Once we have those folders, you can upload the file there. Okay. Give me 1 second, folks. My projector is overheating again. The way to upload it is by going into the folder and clicking on this upload button. Oh yeah, drag and drop. Yeah, someone in the chat says you can drag and drop. Yeah, you can totally do that. Just drag and then drop. I'm gonna do another way, just so it's more compatible with all computers. Right, you can click on upload right here. Upload, and then project RobotCat. Right, so upload it, and there it is. Right, we just transferred the file from Canvas onto our computer and uploaded it to the server. There's our notebook. All right, let's dive into this notebook very briefly. This is some hints on the homework. So I'm going to double click on this. And there we go. That is our homework project. Draw a RobotCat. The goal of this is to use the turtle and draw this shape right here. It doesn't have to look exactly like it, as long as it has the following shapes. Right? A head, some eyes, a nose, some fangs, some ears. Right? It doesn't have to look exactly like it. The solution cell will be down here, right? The code cell. So make sure you can type every single thing in here. It doesn't have to be separate cells. You can put everything here. Put your name here. This is the comment, right? On the very top of the cell, this is a multi-line comment that's encapsulated in triple quotes. So I'll put my name here, Andrew space tac. Okay, let's say you finished implementing your turtle, right? Well, actually, here, let me give some hints. We need to import something. Right? I forgot what the import command is, so I'm just going to go ahead and copy and paste it from the lab or lesson. It doesn't matter. I'm going to copy and paste this import command from the lab into the project because we're going to need it. All right, there we go. Okay, so I imported that, and you're going to have to fill out the cell which outputs this right here. Right, so you're gonna have to do a tu.new. Right, turtle starts here, and then just draw it from there. Right, will people be cool with that? Drawing this stuff. Okay. Let's say that you're done with this. Let's talk about how to submit. It's very similar to the lab, right? We need to download and upload again. Right, so this is going to be a tiny bit just like the lab. Right? Make sure you save it. Right, so I'm going to save it. If you don't save it, you're going to end up downloading an empty notebook. Okay, let's say you finished it. You want to upload it and submit it for grading. Right, so it's saved. Let's download it to the local computer. Right, go to the File Explorer, navigate to where it's stored. In this case, I organized it. Right, I have a folder called Projects. I have another folder called Week 1 Pro Robot Cat. Right, and it's right here. So same thing as the lab. Just download it, right-click it, download. Okay, here's kind of a tricky part. So I just downloaded it. My computer now has 2 copies of kind of the same notebook. Right? So, do people know the differences? Right, there's 2 copies. You might not see it. But yeah, I got 2 copies. All right, which one is the one we want to submit? It's a little tricky. So this original one is an empty notebook. This is the one that we downloaded from Canvas. Right? This one right here is one we just downloaded from Jupyter Notebook. So make sure you upload the most recent one that was downloaded. And yeah, that's the file you want to upload to Canvas. Okay. That's it for today. We just finished lesson 2 on using the turtle. We finished most of the lab on algorithms. Right, most of this lab right here. So make sure you get that submitted by Friday. And we went over hints on the project. Yep, that's it for today. Thank you everyone for coming. Have a great day.